Hey mathematicians, it's Ms. Bone here, and today we are going to work together to generate equivalent fractions. If you're here with me in this group, you might need extra practice, or maybe this is the first time you've done it, and we're going to use those handy dandy fraction tiles to be able to look at two sets of fractions and recognize if they're equivalent or not. Equivalent fractions, that's a difficult word. So why doesn't everyone say it with me? Equivalent fractions. Ooh, I feel like I heard you through the screen. That's a hard word, but we want to first recognize what it is, right? We need to understand what that means when we hear equivalent fractions. So I'm going to share my screen here. We're just going to review or look over exactly what an equivalent fraction is. An equivalent fraction are fractions that are the same value and size. And I'm going to emphasize value and size because they are not fractions that have the same numbers in there. That is not what they are. We're not really looking at the numbers until maybe later on when we start to recognize some relationships. Today, we're really just going to focus on finding some fractions that are the same size. Okay? So we have a picture right here of two sets of fractions. Just going to annotate it. I'm going to draw a line for you. We see some shaded area on these rectangles. And if I draw my line and continue it to the next rectangle, I'm actually noticing, and I think you're able to notice too, that both shaded areas are exactly the same size. Boys and girls, that means they're equivalent. One isn't longer than the other. One isn't shorter than the other, greater than, less than. Oh, I see this piece is big, this piece is real small. Nope. These two shaded areas are exactly the same size. And that's what equivalent is. So now we just need to write them as an equivalent fraction set, right? So we see right here, these shaded areas are named fourths. That's because this rectangle has been divided into 4 equal parts. Once a fourth, always a fourth. So we're going to write that denominator as fourths. And now we have to count how many 1/4 pieces there are in order to come up with that numerator, right? 1, 2. There are 2 1/4 pieces. So the way we name a fraction that is 2 1/4 pieces, we call it 2/4, right? So now we got to go to this other fraction. Well, this other fraction has different numbers in it. Remember, boys and girls, equivalent fractions doesn't mean they have the same numbers in them. It means they are the same size. So let's look at this denominator. This rectangle has been divided into eighths. Once an eighth, always an eighth. So we're going to leave that denominator eighths. And then for our numerator, we're going to count how many 1/8 pieces are shaded. 1, 2, 3, 4. How do we name that fraction? We call it 4/8. Boys and girls, you just watched me generate equivalent fractions by recognizing that 2/4 is the exact same size as 4/8. Now you're going to try it. So you should see a little teeny link next to this video that you're watching with you. If everyone could just go to that link and open it up. When you open it up, it will force you to make a copy of these slides, and you will actually be able to look at the exact same slides that I am looking at here. Very good. Now that we have all opened it, you guys are going to use this first slide for reference, and then we're going to jump over to the second slide, because the second slide is where you're going to show your teacher that you are able to generate equivalent fractions with no problem. We're going to click on our link for our handy dandy fraction tiles that are going to help us visualize those sizes, right? So you're going to click on that link, and as you can see on my window, another window will pop up. If you're on a tablet, you'll just see 2 tabs up top. Laptop, same thing, and you'll be able to bounce in between screens writing your equivalent fractions on the slide and looking at the fraction tiles to generate those equivalent fractions with our fraction tiles, our virtual fraction tiles. Okay, so let's try, I'm in a mood for thirds today. So I think I'm gonna jump over here and I'm just gonna grab the fraction 2/3. And I am going to use these fraction tile pieces to try to find another fraction that is equivalent or the same size as 2/3. So let's just try halves. Halves are a fun fraction. Well, 1/2, well, that's not the same size. Remember that line I drew to sort of be my guide? 1/2 looks much smaller then. So let's go grab another half. See what happens. Oh boy, 1/2. Now we have 2 halves. We've gone too far. Halves are not going to work. Those are not equivalent to 2/3. Let's try some fourths. And boys and girls, you're going to do this exact same thing. You're just going to start playing with these tiles and see. Well, 2/4 was too many. 2/4, sorry, was too little. And then I went and grabbed another fourth, and now it's too many. Now I've gone past. I'm not the same size. So I guess fourths can't be equivalent to 2/3 either. Let's try 6. And you know, it's interesting because I'm thinking to myself that 3s and 6s are actually related. 6 is a multiple of 3. I wonder if that's going to mean anything when we go to, oh my goodness, let's look at our guide. I started grabbing 6 pieces, and as I started placing them against my 2/3, I was able to see that 1, 2, 3, 4 1/6 pieces is exactly the same as 2/3. So I'm going to come over here. I'm going to write my equals. And how do we name 4 1/6 pieces? Well, 1 to 6 is always a 6. And then 1, 2, 3, 4 of them makes 4/6. And for you to have that slide to be able to show your teacher, you're going to jump right over to back to the slide. You're going to quickly double click on those boxes you see there, and you're going to plug in those numerators to show all of the amazing equivalent fraction sets that you have generated today. We just recognized that 2/3 is equivalent to 4/6, and we're going to jump back to those fraction tiles, and maybe we erase them and we try all over again. Let's try halves this time. Good luck, mathematicians. I know you got this. Generate those fractions, meaning they are the same size. Good luck.